Good morning, dear students. Welcome to the class of Advanced Pre-Stressed Concrete Design. In the last class, we discussed about the shear resistance of pre-stressed concrete structures. Now, we are going to discuss the problems related to this topic which were asked for previous year university question. This is a reference textbook Pre-Stressed Concrete Design by N. Krishnaraju. Now, moving on to the problem. This was our question. The support section of a pre-stressed concrete beam 100 mm wide and 250 mm deep is required to support an ultimate shear force of 60 kN. The compressive pre-stress at the centroidal axis is 5 Newton per mm square. The characteristic cube strength of concrete is 40 Newton per mm square. The cover to the tension reinforcement is 50 mm. If the characteristic tensile strength of steel in stirrups is 250 Newton per mm square, design suitable reinforcements at the section using Indian Standard Code IS 1343 recommendations. Okay, now we have understood the theoretical aspects of the question. Moving on to the solution. By reading the question, we can understand certain given data. First of all, let's analyze that. The support section of a pre-stressed concrete beam 100 mm wide and 250 mm deep. So from that we know the width BW and the depth 250 mm is required to support an ultimate shear force of 60 kN. Therefore, V is 60 kN. The compressive strength at the centroidal axis is 5 Newton per mm square. FCP is 5 Newton per mm square. Next, the characteristic cube strength is 40 Newton per mm square, which means FCK is equal to 40 Newton per mm square. The cover to the tension reinforcement is 50 mm, which means the total depth is 250 mm and the cover is 50 mm. Therefore, the effective depth is 200 mm, that is 250 minus 50. If the characteristic tensile strength of steel is in stirrups is 250 Newton per mm square, that is Fy, then we need to design. Okay, so for the support section, we are considering the uncracked case. For the support section, uncracked in flexure, we know that from IS 1343 close 22.4.1, we know that VC is equal to VCW is given by the equation. In that, let us look. BW we already have, H we have, FT. FT can be determined by using an equation 0.24 root FCK. Therefore, FT can be determined in this way, and FCP, it is already given in the question. In that way, we can calculate FC, and we obtain the value of VC as 48.4 kilonewton. Now, we have the value of V as 60 kilonewton, and we obtained the value of VC as 48.4 kilonewton, which means V is greater than VC. V is greater than VC. It is a critical case and shear reinforcement should be provided. Therefore, the balanced shear, the unbalanced shear is V minus VC is equal to 60 minus 48.4, that is 11.6 kilonewton. Assume that we are using 6 mm diameter 2-legged stirrups. Spacing is obtained as SV is equal to ASV into 0.87 FYD by V minus VC from IS 1343 1980 22.4.3, and we obtained the spacing. And there is a condition that maximum permissible spacing is limited to 0.75 D, that is 0.75 into the effective depth 200. So it is obtained as 150. Therefore, we came to the solution adopt 6 mm diameter 2-legged stirrups at 150 mm center to center. So this is how we work out a problem relating to the shear resistance.